This section looks at the master cylinder in ABS. The master cylinder is connected to the brake pedal via a push rod. The ABS master cylinder is similar to the tandem master cylinder used in divided systems. It has a primary piston and a secondary piston. The secondary piston incorporates a center valve. This controls the opening and closing of a supply port drilling in the piston. At rest, the supply port is open and connects the reservoir with the front brake circuits. The primary piston still has an inlet port and a compensating port. When the brake is applied, the primary piston moves, which closes its compensating port. Fluid pressure in the primary circuit rises. It acts with the primary piston spring to move the secondary piston forward, closing the center valve. Pressure builds in the secondary circuit. Pressure keeps building in both circuits and applies the brakes in both circuits. If the secondary circuit fails, the secondary piston is forced to the end of the cylinder. When it reaches the end, pressure builds in the primary circuit. If the primary circuit fails, the primary piston contacts the secondary piston and pushes it to operate the secondary circuit. In normal operation, when the pedal is released, the springs in the master cylinder push the pistons back more quickly than the fluid can flow back from the wheel brake units. This creates a low pressure area in front of each piston. Such low pressures can cause air to be drawn into the system. To prevent this, there are recuperating grooves in the primary piston and the seal. Fluid at atmospheric pressure flows through the inlet port and past these grooves. When the primary piston is returned fully, any extra fluid coming back from the brake units displaces fluid into the reservoir through the compensating port. In the secondary circuit, fluid also at atmospheric pressure is forced back into the inlet port. The inlet port connects with the supply port drilling in the piston. Any difference in pressure lifts the center valve from its seat and lets fluid enter the chamber ahead of the secondary seal and prevents low pressures developing. When the piston has returned to the rest position, the seal is pulled off its seat by the action of the link and spring. This lets fluid still returning from the wheel units displace fluid back to the reservoir. If braking conditions are such that the hydraulic modulator must return brake fluid to the master cylinder, then for the front brake circuits, fluid is returned to the front section. This forces the secondary piston back against the force of the primary piston spring and the rear brake pressure. If enough fluid returns, the center valve opens and allows fluid to return to the reservoir. If fluid is returned from the rear brake circuit, the secondary and primary pistons tend to be forced apart. The amount of fluid that returns to the master cylinder is determined by the degree of anti-lock braking control. With approximately 4 to 6 ABS control cycles per second, the rapid changes in pressure cause pulsations that can be felt by the driver at the brake pedal.